exciting edition of mathematics being made easy. Today we want to look at the trigonometric ratios. But before we look at the trigonometric ratio, we need to know something small about right angle. Then from the right angle, we can move to the right angle triangle. With that, it will help us to understand the concept better. What then is a right angle? We normally say that what a right angle is an angle that measures exactly 90 degrees. An angle that measures exactly 90 degrees is what we refer to as a right angle. So this is a right angle, which is not drawn to scale. This is a right angle. So whenever you see something like this is what we call a right angle. So this tells us that it is what? 90 degrees. It tells us that it is 90 degrees. Are we getting the point? So this becomes right angle. Right angle. So this right angle can be converted into a right angle triangle. Triangle, you know that it is an angle that has what? Three sides. Three sides. So what do you think can be done so that this angle that we are having here, which is a right angle, can be converted into a triangle? What we need to do is that we just have to draw a line from the top to the down here. So when that happens, then we have three major sides, 1, 2, and then the 3 sides, as drawn here. But this one is not drawn to scale. So this is our what? 90 degrees, telling us that it is right angle, then triangle. So we have our A, B, C. So this is our small a, this is our small b, this is our small c. So this now is called what? The right angle triangle. Right angle triangle. So this is the name for this. So when you look at these things, this is what Pythagoras discovered, one of the Greek philosophers and also a mathematician. So by Pythagoras. So what did he say? He said that the longest side. How are we going to know that this place is the longest side? How are we going to know? There's one way of helping us to know that this is the longest side. Have you seen where the angle 90 is? Where the 90 is facing, that becomes the longest side. Where the 90 is facing. Where do you think the 90 is facing? The 90 here, this angle 90 is facing this line AB. Into bracket the small c. Line, BC. It is facing what? This 90 degrees is facing this BC. So with that, Pythagoras said that the longest side is called hypotenuse. That is the name he gave it. So the longest side, which is what? The BC. So our BC is called what? The hypotenuse. That is the name given to it. Then, what is the name of the other sides? So far as this place BC, like BC is having a name, hypotenuse. What do you think will be the name of AB? Now, Pythagoras said that we need to introduce an angle, which we call theta. This is the angle theta. So, it can be here, it can be here. There is an angle here already, so we can use this. So we only have two options: use this side or this side, the angle here, or the angle here. So, this is it. Where the theta is facing, has a name. So it is facing line AC. So line AC, there's a name for it. Pythagoras said that the name is what? Opposite. So AC has the name to be what? Opposite. Then, where the angle is lying on, the theta is lying on AB, line AB. So line AB becomes the what? Adjacent. It becomes the adjacent. I hope you are following. Likewise, the angle can be here. If the angle is here, it means that it is facing this area, AB. So line AB becomes our opposite, whilst line AC becomes our adjacent. I hope you are getting the point. I believe you are following. Then Pythagoras also said something. He said that what? The area of the square, the area of what? The hypotenuse. The area of the hypotenuse. You know that area is what? Area is what? Square. I related the square. So the area of what? The hypotenuse. The area of what? Or the area of the square formed by hypotenuse is the same as or is equal to the sum of the area of the square of what? The opposite and the area of the side, the area of the side formed by the what? Adjacent. So in mathematical terms, we have what? So the area formed by the hypotenuse. So which is what? C squared is equal to the sum of the area formed by what? The opposite, which is A squared. And we talk about the sum is addition. So A squared added to what? B squared. So this is what Pythagoras said. Then, now let's look at the what? The trigonometry or the trigonometric ratios or the trigonometry ratios. Good. What does that mean? We have three major types of trigonometric ratios. We have the sine, is the full word. The short form is what? The sine. Then we have the second one, which we call the cosine. Short form is the cos. Then the third one is the tangent. Tangent, which we call the tan. Now, what is the value for this? When we say sine, what is it equal to? So basic trigonometry tells us that sine of the angle theta simply means that where is the angle facing? It is facing the opposite, which is what? AC. So sine is equal to what? Opposite over the hypotenuse. Hypotenuse. So the opposite is what? Is AC. AC all over what? BC, which is the same as A over C. A over C. I hope you can see that. Then we look at the cosine. Cosine, or the short form cos theta. Cos theta, where is the angle lying on? It is lying on line AB, which is adjacent. So we say that cos theta is what? Adjacent all over what? Hypotenuse. So adjacent is what? AB all over BC. Our AB is B and our BC is C. I hope you are following. Then the last but not the least is tan theta. Tan theta is also where is the angle facing? It is facing AC. So AC, we know that it is opposite. So opposite over where the angle is lying on. It is lying on AB. So we have opposite over adjacent. So opposite is what? AC over adjacent. Adjacent is AB. Good. What's the opposite? The alphabet for AB is what? Sorry, AC. Opposite is A. Then BC. Sorry, AB is B. So these are the trigonometric ratios that we have. So with this, students or people decided to make it easy for students by getting some acronyms for it, so that when they remember the acronyms, it becomes very easy. So with that, they came out with what we call the SOH CAH TOA. The SOH CAH TOA. SOH CAH TOA. So for the SOH CAH TOA, when you take the whole of this, the SOH, the S stands for sine. You see, the S stands for what? The sine. So sine theta is equal to what? The O stands for opposite all over hypotenuse, as we have here. Then the CAH stands for cos. So the cos theta is equal to what? Adjacent all over hypotenuse. Then the last but not least, we have the tan, which is what? The toa. So T stands for the tan theta, then O stands for the opposites, and A stands for adjacent. I believe you have enjoyed today's lesson. Thanks so much for being part of this lesson. When we meet again, we will now learn about the trigonometric identities, the various identities that we have as far as trigonometry is concerned. So when we meet again, we'll talk about that. Thank you very much. Bye-bye.